A swimming pool is circular with a 40-foot diameter. The depth is constant along east-west lines and increases linearly from 2 feet at the south end to 7 feet at the north end. Find the volume of water in the pool. The surface of the water is a circular disk D with a diameter of 40 feet. That means the radius is 20 feet. If we place the origin at the center and define the positive y direction to be north, and f of xy to be the depth of water at the point xy, then the volume of water in the pool is the volume of the solid that lies above D, which is the set of points xy such that x squared plus y squared is less than or equal to 400, which is the square of the radius, and below the graph of f of xy. We know that the south end of the pool has a depth of 2 feet and the north end a depth of 7 feet. So f of 0, negative 20 is 2, and f of 0, positive 20 is 7. F is independent of x. We can create a trace in the yz plane, which is the line segment from the point 0, negative 22 to the point 0, 27. This line has a slope of 7 minus 2 over 20 minus negative 20, which is 1/8. So an equation of the line is z minus 7 equal to 1/8 times the quantity y minus 20. Or solving for z is equal to 1/8 y plus 9/2. Because f of xy is independent, f of xy is defined purely by the y dependence, which is 1/8 y plus 9/2. This is the function that defines the depth. The region D is the set of points r theta in polar coordinates such that r is between 0 and 20, and theta is between 0 and 2 pi. Making the substitution that x is equal to r times the cosine of theta, and y is equal to r times the sine of theta, the integral for the volume, v, becomes the integral from 0 to 2 pi of the integral from 0 to 20 of the quantity 1/8 r times the sine of theta plus 9/2 times r dr d theta, where the expression in parentheses is f of xy in polar coordinates. Evaluating the radial component of the integral, we're left with the integral from 0 to 2 pi of the quantity 1/24 r cubed times the sine of theta plus 9/4 r squared, evaluated at the endpoints, d theta, or the integral from 0 to 2 pi of the quantity 1000 over 3 times the sine of theta plus 900 d theta, which comes out to the quantity negative 1000 thirds cosine of theta plus 900 theta, evaluated at the endpoints, which is 1800 pi, or about 5,655 cubic feet of water. This is the volume of water in the pool.